Hi everyone, welcome to today's webinar. So my name is Jimmy, who is introduced by Sergey. I'm a HPC consultant at Chocolate. So Chocolate is a part of Compute Ontario and also part of Digital Research Alliance of Canada. So today I will talk about running MATLAB on Alliance clusters. So MATLAB is one of the software heavily used by our users on our clusters. So over the time, we saw all kinds of issues, and on the supporting side, we try to help users as much as possible. And we talked about MATLAB on our clusters back a couple of years ago. So today, I plan to cover the topics. The first is a general update or as a refresh of the current status of MATLAB on Alliance clusters. And then the standard way to run MATLAB jobs in Saloon. And the most part of today, I will focus on parallel computing toolbox in MATLAB and how to actually run it on our clusters. And then I hope to cover the MATLAB Compiler and Runtime and provide a lot of way for you to run MATLAB on our systems. So certainly there is another way to run MATLAB interactively, and that's not something we actually recommended you to do on the clusters. So I may not cover that today. So I think all of you know, because you somehow usually run your MATLAB or whatever systems on softwares on our clusters. So at the moment, Alliance clusters will have 5 big clusters. 4 of them, we call it general purpose clusters. So it's Beluga, Cedar, Gram, and Narval. So we do have a large parallel cluster to run large scale parallel jobs. That's Niagara. So for MATLAB, right now, MATLAB are on all clusters. However, it's actually is on all the 4 general purpose clusters. So it's not on the largest scale and Niagara clusters. So you all know MATLAB is a commercial package. So commercial package comes with a license. So luckily right now, I think some of you are aware, we have free license for you for any Alliance account holder to run MATLAB on Beluga, Cedar, and Narval. So regardless where you are come from. We have MATLAB on Gram as well. However, Gram does not have a free license to our users. Instead, it uses your institution set license. So right now, we actually configured some universities. So I listed here. So these universities, you don't need to do anything, and you just run MATLAB as you run on the other clusters. So if I come from different institutions, unfortunately, you cannot run it on Gram. And so we will recommend you to use the other clusters. And it's a good thing. And for those, you have to run MATLAB on Gram. So certainly you are registered with your local MATLAB license. So you are in the MATLAB license pool at your local institutions. And then your local institutions will have your local institutions user ID recorded in the license file. So your previous Computer Canada Now Alliance account, that user ID, username should match your institution's username. Otherwise, it will throw a license check error. So if you find a license check error, you will know what's happened, or you let us know. We'll try to help you. Okay. So because our clusters were installed at a different time, so right now, if you go to a different cluster, and if you want to find which MATLAB is available, you'll find they are different. So MATLAB is installed as a module software. So you use module command to find it. So because Gram, Theta, and Beluga, 3 of them, they are installed quite back a few years ago and around the same time or close to each other. So we have lots of MATLABs on those 3 clusters. So if you type modules by the MATLAB, you'll find the oldest 2040A all the way go to 2020B2. So traditionally, MATLAB has 2 major versions per year. They have comes with A or B. Now since 2020, they come with many the minor versions. So we are trying to have some minor versions on it as possible. And sometimes they come too many. So you can say that .4 or .6 or something. Yeah. If you don't specify the versions, you just type your module load MATLAB, it always load the latest one on the system. On Narval, if you try to find what MATLAB is available, so the newest version is 2020A. That's because Narval is a newer cluster compared to the other clusters. So we don't have the old MATLAB versions on it, and we don't need to, because I think for your people really will use the old MATLAB versions. So it may make sense to remove the old MATLAB versions at some point. So the MATLAB versions right now is 2022B.2. That's the latest MATLAB versions you can use. Okay. So because MATLAB is installed as a module software, so you can use it, use a module command. I think the first thing you need to know is to say which versions you'd like to use. So you always type module spider MATLAB, and then you type module spider MATLAB / version, and to find exactly what command you need to use. For the MATLAB 2020A and the later versions, you just need to use module load the MATLAB. That's because right now the default user environment is the standard 2020, and MATLAB since 2020A was built on the default environment, so you don't need to do anything. So if you happen to need to use the old MATLAB like 2019B and earlier, and then you need to switch to the old environments and to be able to note it, because the old MATLAB was built on the old default environment. So let's next package is 16.09. So you need 2 lines. You need to node this first, and then you node MATLAB 2019B and earlier versions. Okay. So the other thing I think most MATLAB users may be not aware of it is when you start writing your MATLAB MATLAB code, it's actually it will create runtime files by default on the .MATLAB folder and directories. So by default, it's created under your home directory. So here I copied the lines to show you by default. So originally I have all tests run on Theta cluster, for example. So if you check, you can find you can have a hidden .MATLAB. So normal case you cannot say it is hiding there. So you go there, you can find. So I have a bunch of files. I didn't even aware of it if I don't want to. And now or in future trends is said on some clusters, the computer node may not be able to write files under your home. So the home directory, those files may be only readable. So in that case, we actually put a script on our MATLAB wiki page to actually encourage you to create data MATLAB folder or directory under your Scratch, not in your home. However, by default, and the MATLAB also find the default under your home. So you create a data MATLAB under your Scratch, and you create a soft link and from your home. So by that way, you will not have any problems when you run MATLAB and its runtime files, some informations, and it's on the in the background. You don't even need to know about it. So in that case, basically, and if you have a MATLAB already, you have run it on cluster, you can run a script like this, and basically it remove your current MATLAB to be under your Scratch, and you create a link. Or if you don't, it's okay. You just go to Scratch to create a new data MATLAB directory, and you use create a soft link to it. And then you go to check. Right now, you can find under your home is not the data MATLAB physical directory. It's actually the soft link to your Scratch data MATLAB. Okay. So this is something to prepare your MATLAB file. And actually, you can say under my MATLAB, there is a file called a subdirectory called locals cluster underscore jobs. So when you run parallel MATLAB jobs, it will create such a directory. And then if you go to that directory, you can find a bunch of files. So you may have an issue when you run a couple or a bunch of parallel MATLAB jobs, use the parallel computing toolbox simultaneously. You may have a conflict for some files, runtime files there. So in that case, you may need to set up a temporary runtime files per job to try to prevent from that file conflict. So we have such explanations on MATLAB wiki page as well. And I don't cover it today, so you somehow may need it, and you follow that instructions. Okay. So the second part is, as I said, MATLAB is just as one of the software you run our clusters. So you can run it as a regular, any type of software as a regular job in our Sloan and scheduler. So here I gave you an example, a shorter, it's a demo, it's not a demo. However, it's some, I use some screenshot. It basically is a demo on the slides. So to see, to let you see from step by step what I'm doing and what I try to explain to you. So here I use the example is a simple code to calculate pi in MATLAB, and it's a simple MATLAB code. And it's basically use a for loop and to calculate pi approximately, and by the numerical integration, it's just one equations. So if you code it in pi in MATLAB, so you can just use one for loop. You can calculate that function, and with this kind of divided to how many small parts and how many iterations to go, and you will do it. And you have a MATLAB code, and MATLAB can actually compute the timing things and tick-tock. And later I use it, and I actually will show you the performance later in later slides. So you have a code, and the next thing is you prepare for a batch script. We always call it a .sh file, and it's just like a regular one. You also need to set up your account. So for me, it's default. Some you have rack account, and then MATLAB is a sequential code just now. So you specify how many CPU to use. And then you need to specify how much memory to use, right? And then how long to your job need to run. So this is a standard thing. And then you specify a output. And then you need to module load MATLAB. So I use, say, 2022A. So that's it. And when you run MATLAB, you don't forget to put these two options after MATLAB. Is dash no display. This basically to turn off the GUI. So it's a batch job. You don't want the GUI to start. And then you need to specify single COM thread. So you want to use a single thread because you use one CPU. And MATLAB is an auto-threading software itself. If you don't use this, it can, some cases, it can create tons of threads, and it's not good for your code. It will not run any faster. It actually will make trouble on the hardware side on our systems. And then it's -r. This is you have a for_pi.m code. Use this way to write, or you can use a different way. For example, you can actually specify the input file -input for pi.m. In that case, you don't need to put -r to run the code on the run command. So this is other way in your .sh file. Certainly, you can have many other options as other jobs in your .sh command, .sh file. So if you have that, and then you basically submit job, right? When you submit job, the job will run, and then the output you can find something like this. So always come with MATLAB and what versions it used, and what's the time it used, and then is the result output, right? So this is sequential job is like a regular sequential jobs, nothing specific, and just you need to have that no display, that single COM thread in you start to run MATLAB. Okay. So we move on, and for the bigger part I'd like to cover today is the MATLAB parallel solutions. So MATLAB actually provides two solutions. One is called MATLAB Computing Toolbox. So this is a shared memory parallel solution, something like the OpenMP or pthread, those type of parallel approaches. And the other one is called MATLAB Distributed Computing Server. We usually have that on all the sharded clusters, and we stop the license at some point. And now it's actually Quebec, they have that distributed computing server available installed on Beluga and Lua. So if you happen your institutional MATLAB license covers that distributed computer server, you can go to configure it and try it yourself. If not, and will not encourage you to do it. I'm not covering it today. The configure and the local configuration is actually take quite some time, and basically is a client server model. So you need to have MATLAB, the whole package, including the distributed computing server, installed on your local laptop. And then you run from your local laptop. And it seems like you are running on your local machine. It's actually, under this, is actually run on a remote cluster. So it's like sort of like is a client server model and like a virtual machine or something like that. And we had done that before, and we don't cover it. I don't cover it today. And then what I cover today is for the shared memory solution. And in parallel computing toolbox, they come with three major constructors to do parallel. The one is like path 4, is to parallel your for loop. So this is the simplest, straightforward way to do it. And the other one is called SPMD, and it's used to parallel tasks, not loops. So you know, some code is there's no loop, right? You can actually divide your job as tasks. And then the other one is called par favor. So this is another type of task parallelization. Is to run functions and parallel pool workers. So it's slightly different from SPMD. I will explain it later. So next one is say which one to choose. Certainly, in most cases, you'll use a par 4 because for loop is the major sense in scientific computing software, right? So you use it, it's okay. And then if you don't like to use SPMD or par favor, and then you need to understand what's the difference there. So I put here the difference and want to let you know. So it's basically, if you're not sure, so you will know so whether the task you planned to do to run by each workers are they really needed to communicate with each other or not? If they do, you use SPMD construct. If not, that means they are purely independent. It will run its own. They don't need to communicate with the other MATLAB workers during the run, and then you use the par favor. So today I have examples to show for par 4 and the examples for SPMD, and I don't have examples for par favor. And I think it's quite straightforward. And you can go to MATLAB documentations to check it out yourself. Okay. So the major thing I'd like to focus is actually how many workers to use, because that's maybe not important to you, to users of MATLAB, but it's important to us. And we, as a MATLAB supporter, we hope and we try to have our systems, hardware, used as efficiently as possible. So we always focus on the performance side. And sometimes in your side, you think, well, as long as my code will run a little bit faster, I don't care how much CPU set you use. And we do care. So that's why at some point, we need to have a balance. So we want you to run your code as fast as possible. In the same time, we want you can use our systems, our CPUs as efficient as possible. So what does PCT do? Because it's a sort of automatic thing, it's a default thing. So you need to have a basic idea how it invoke those parallel workers. So without anything in the code, MATLAB code start. So when you first say the par 4 or SMP, that type of command, it assumes that will start a parallel run. And then it will automatically create a bunch of parallel workers. Certainly that depends on how many CPUs you give to your job. So it's quite hardware dependent. So the number of workers on cluster. If you are given that CPUs is less than 12, it's always trying to open that many workers as the number of CPUs. If you give it the CPUs is more than 12, however, MATLAB by default is 12. So if you even give more, the MATLAB only open 12 workers, and the worker use 12 workers by default. So in that case, so if you happen needed to use more than 12 cores, then you need to do something. And then in your MATLAB code, you need to use another called par pool, that command, and to set up the number of workers you'd like your code to run, to override the default. So that's the key. Some of you don't care, and I hope you care. Okay, so I have quite a few demos for you. It's on screen to see it. So right now it's the same code from the sequential code. So if you compare this code with the previous code, the only difference is change the 4 to power 4, nothing else, right? Because nothing else, just the 4 changed to power 4. And by changing that, now your code can run in parallel, use multiple CPUs or multiple MATLAB workers. In this case, and then if I say I set up 16 CPUs, so I gave you, say, okay, you have 16 CPUs physically, you can run your code. It's okay. And what you need to do is here, there's nothing else will be changed, except in the MATLAB command line, you still need to -no desktop, this one. However, you need to remove the -single comma thread options because you are using more than one CPUs. It's not only one CPUs now, so you don't want to limit that. And then you can, and the job will run. So when you submit this, and then you can say your results. So you can say just now, I actually gave it 16 CPUs, right? And then I don't have anything in my code. And then you run this job, the output will be here like this. So when you hit the power 4, the code starts in the parallel pool and use the local profile by default. And in this case, it will automatically, it will open 12 workers. And then the 12 workers and will do the job, and the result is correct, right? So as I told you, is that if you give more than 12 CPUs, you will not use that by default. The maximum is use 12. So in this case, you have to do something and we'll check. However, if you go back and do a test, say this time, and change it to 4, and then you can say, I said, if any CPU gives under 4, it's fine. Under 12 is fine. In this case, if it's 4, it gives you, say, it automatically is correct. Number of workers is 4. So to make sure each CPU is work as one MATLAB worker in MATLAB's sense, and then it will get the job done, right? So that sense, so when you need to use more than 12, so here is my example, and so if you say sometimes say, well, use 20 is okay. And then what you need to do is you need to add another 9 in the simplest case. So it's power 4 and 20. That means you tell MATLAB this time I need to give it, give it 20 CPUs, and you need to give 20 CPUs in your .sh, that script. And then your MATLAB code is say, I'm going to open 20 workers. And then when you have that, when you come to the power pool, it will not open default anymore. It will use your 20 workers to do the job. So that's important for the power pool. And certainly in the complicated cases, so this is actually when you have the 20 defined, it will actually is connected to 20 workers. And in this case, right? So in this case, it's basically you say you have more ways to control, to manage how to run MATLAB jobs, to use more resources in a better way. So my example is the simplest, use the default local profile. And you know, some of you, if you have started use a parallel toolbox, you know you have more ways to do it. And you can set up your own profile, and you can set up your own script, so including the location of your files and including how many, what type of other functions you need to, options you need to include it in your profile to make it more meaningful to your own research. So then the question will be, how many CPUs can I use? And theoretically, is the maximum CPU you can use is the maximum CPUs on a load, because on one node, all the CPUs can share memory. Cross node, they don't. So you cannot ask more than the CPUs on one node. So on Narval's case, so my examples, many of them, they run on Narval, the latest cluster. On Narval's case, the majority of load, they have 64 CPUs. So that means the maximum CPU you can use is 64. And then 64 on our cluster, the majority of load, they come with 2 sockets. So it's actually 32 per socket. So normal case is the CPU on one socket will run more efficiently for shared memory jobs. The more CPUs, then will have more overhead, and then it may slow down. You can run up to 64 CPUs on Narval, and then you can run up to 32 majority of the clusters on Gram, on SATA, or different on other clusters, because we have some clusters, they come with mixed loads, some with 32, some with 40, some with 48 or something. So this doesn't mean you have to use, you will use the maximum always. No, it purely depends how big your job is. The bigger your job, as we said, the bigger data your job is, and it makes sense, and to make more CPUs. Otherwise, it doesn't make sense. You may just waste off. So I'll answer your questions later afterwards. Okay. So here I had a performance test, and I ran it back a few years ago, and I rerun it now, and to give you an idea. So for the same par 4, calculate 4 par pi data code, exactly that code, and you can use different CPUs to run it. So this is all the time I used the 2018, and that time Gram was a new cluster. Okay. And then use different to see how good the code is running. And it actually makes sense. And then, when you increase the CPUs, you get a speed up and reasonable, and it looks like 50%. And we think 50% was good at that time because it's shared memory things. Okay. And then, however, if you're over 16 and you found the speed up was not good. So you double the CPU, your runtime doesn't actually speed up quite good. And this results make sense because Gram at that time is 16 CPUs per socket. So if you run over 16s, it'll slow down, and it makes sense. So in that case, I will basically encourage you you don't use over 16s for the problem, for the code I have. And now I use the same code, and then we'll run it on Narval. So we found the same code on Narval is quite interesting, and because the data size or the runtime, it depends on the iterator, the size I defined in the code, right? So I defined that this size is exactly I used before, and you can find it. It actually lowers. Narval's CPU actually has much better parallel results. So close to 4 or close to 8 or close to 11, something like that. And then when it's over 16, it doesn't increase at all. And even go to from 32 to 64, it actually is worse, and it's close. So it doesn't make any sense to use more than 16 CPUs as compared to Gram. Seems to be the same. However, when I increase data size by 100 times, and then your code will run 100 times longer, and you have more data to spread to more CPUs. In that case, You know, you can find even the same code is just we have more data, right? And it can run longer. And then you actually make sense when you go to making more CPUs. So I think this is meaningful. Is say, you know, when you want to use more CPUs, you really need is big data. You really and has enough tasks or data to be calculated per CPU. Otherwise, your time is spent on overhead or on I/O, and you don't have gate like this because when each CPU just get a little bit job to do, and it will not make sense to use more CPUs. So that's the thing. So it's not only for MATLAB; it's in general for parallel jobs. So someone just like to use hundreds or thousands of CPUs and to run parallel job. Certainly, the software can run that scale. However, in many cases, your application, your research don't really need that to use that many. And instead, you can use that many CPUs to run multiple jobs instead of have one huge jobs. And that will benefit for you, and also it's friendly for our clusters. Okay. So that's the thing. And for part 4, and for the performance and showed. So I can run quickly now, and analysis is SPMD. So SPMD, I always said, is not for loop. And in some cases, if you don't have a loop, you still can try to parallel your code and use parallel tasks. So it's quite simple. It's the syntax is SPMD, and whatever your task you want to divide it to number of workers, and then it comes with the end. So that means whatever between will be run in parallel. And then the system is actually when you open a parallel lab, it will have a lab index, it will number of labs. And then SPMD, it has its own index, and it has its own size. So it actually automatically to distribute the tasks, it will know how much to do. And you can use the index and the size to divide the tasks to each workers. So I use the same examples to calculate pi, but this time, instead I use the for loop, I go to another approach without the loop. And then this is actually example provided by MATLAB. You can search it out. It's on MATLAB website to introduce the PCT SPMD. So it's the same formula. It's calculated the integral across, say, from 0 to 1. And it's basically the calculated area in this area. So certainly, and manually, you can say you can use different workers and let each work on part of the formula, and then at the end you add them together. So the more workers you use, and assume the better results you will be, and then maybe the balanced result will be. Otherwise, so different worker will get a different chunk of job. The tasks is not evenly distributed. But here, I'm not talking about that performance anymore, and I want to just demo how does SPMD work, right? So in one CPU's case, it's okay for one CPU to carry the whole integral from 0 to 1. And if I have 4 workers, and say each will work a part of them. If I have more, certainly each will get a smaller chunk. So in this case, so the steps will be, you have a formula to do. And because I said, when your MATLAB, you automatically have each lab, you have an index, and they have a total labs, how many labs will have. And you can use it to actually manually to define the boundary of or they call the sub-interval of your lab. So let each worker will work on the region, say from A and from point A to point B, right? And the MATLAB come with a method to actually to calculate integral instead of the loop. And then by the end, MATLAB come with that add together and like a G plus is a type of sum command in MATLAB. You can get it done. And then you can say this code is a sequential code, okay? And this is say basically is a formula to run, and then you can define A and B and each and to do it. And then you do the integral and whatever. So the trick will be that the interval will be here, right? Right now I didn't use SPMD, so this code will run and use one CPU. So if you use one CPU, so that's different from your sequential MPI code. So you have specify one. The same thing is you use a single computer node. You run this code and you go to check the output. It will give you output. So you use one CPU. There's no, it doesn't start parallel pool at all. So basic subinterval is all, it's just one, right? Use one CPU, you calculate whole, you get results. And then now I want to do parallel in this case. And then what I different is I added that SPMD command starting from here, and then the end is there. So that means it's each CPU will calculate it, and each will add calculate its own integral, and then we'll add them together. So in this case, I didn't specify how many ports to use, right? It's the same thing as the part 4. And then, so in this case, so I use this .sh script to run it. So what is I use 4 CPUs, and basically, and MATLAB will open 4 workers. And this is just remote at dash single comma thread. Otherwise, there's nothing changed. So each run this you found is actually run in parallel, right? It's run in parallel. In this case, it's actually used 4 MATLAB ports. In our case, it's 4 CPUs, 1 CPU per workers. And you can find each work come do a partial of the integral. So work 1 work on from 0 to the first quarter, right? The work second one, second, the third, last one, the last quarters. And then we'll get results. You can find this SPMD works, right? And each will work its own, and is perfectly, it's run in parallel. And if you want to run more, use more CPUs, it's okay. And I tried it, use 16 or use more. However, as the same thing, if you want to use more CPUs, and then, for example, more than 12, you need to add per pool, say 16, for example, before SPMD. Otherwise, SPMD, the maximum is open, is 12, okay? So let's a simple thing for SPMD, and the focus is say per pool, you want to specify the number of CPUs to match what you give in your .sh script. Now I talk about last part is for the compiler and the runtime library. So if you go to check what compiler and the runtime library, so the short name is MCR. Again, on different clusters, they have different versions. On the older cluster, we have more versions. So each is comes with A, B as well. And on lower, we have these 2 versions. So the latest one is 2021B. So we don't have 2022 yet, but it will be there at some point. So the steps for MCR, well, the first thing maybe is say, when should I use MCR? Certainly, they may have many reasons to use it. I think right now, I can tell you it's 2 major reasons. One reason is, for example, some users, you cannot run MATLAB on GRAM. However, you want to use GRAM, or maybe because you have a rack project on GRAM. So in that case, and you can compare your code on SIDA or on Beluga, and then you can bring that compiled standard non-binary code to GRAM. You can run it on GRAM without need a MATLAB license. The other most common thing for you to do is you want to run the same code many times, multiple times use different input files, such like a sort of Monte Carlo simulation type of calculations. Some users they need to run tens, hundreds, or thousands of jobs, use the same code. And in that case, you will make sense to compare it and run it. And then is actually the third reason, if in that sense, compared code run more efficiently, just like a compared C++ code, it will run more efficient than the MATLAB, because the MATLAB each time they need to open MATLAB, whatever, and spend time in overhead. So the steps further sense, certainly you need to compare it. You compare it, you need to use one of the MATLAB versions. And then you certainly need to use the MATLAB versions to match the MCR versions. Right now we have MCR 2021B, so the MATLAB you have used, the latest should be 2021B. Different match versions do not match, they will give you error. Okay. The second thing is what options I need to use, and to my MCC that command is a compiler command. Certainly there are a bunch of them. So the simplest one I can recommend is, hey, use -m. -m is generate a standalone binary, and then use -r. -r because we basically use it for sequential code. So you add these two and no display and a single computer thread, and to make sure it will no windows and it will run one CPUs. And certainly you go to MATLAB, you can find many other options. It's up to you to use. And then you have that, and then I can show you quick here, say what you will get. So my demo was done on Narval. So I have this directory created, and it's under my project and under one MCR, I use 2021B. So at the very beginning, I only have two files under my two files there. So basically, I only need a .m file. That's nice that calculate pi data sequential code, and I create a .sh file. Use it later anyway. And then I use that 2021B and I run this command, right? This is basically compare this .m file, MATLAB code. So if this command runs successfully, so we can say this, when you come back, you say these files are created after I run the command. So there are 7 of them. And among the 7 of them, 3 of them make sense. You will take a look. The first one is this 4_pi. This is a standalone binary. Like you compare to C code or C++ code. You can move this and to allow the cluster to run it. And then the other one is readme.txt is a text file, and will tell you how to run it. And then it create actually .sh is a run script, and this is a temporary script and can tell you how to grab the MATLAB environment to be able to run it. So readme.txt tell you how to run it. You need to run this script, come with the path, the full path of your MCR. So when you run it, you have this. So next thing, you need to find the full path. So you find the full path is a little bit of trouble. And then the next thing, so you want to run it, you need to load and MCR, right? And then I load MCR. And then I try to find it because it's easy build. You need to find the easy build road. And in that case, you can find it, and you find the sub version is V911. So this is the whole path. And then when you run it, and you need to add this to the whole path. So this is script. So this script is one CPU, all the same. And then you run this script, and then this is the whole path we will give, right? You submit it. After you run it, you'll get this .log file, right? And then when you do that, you can find it. So it will say, we'll run this, or it's actually getting to run. And you can find it's actually linked to that is 2021 V911. That's the path, set up all the environments. And after run, you give let's results. So let's compare your code and run it. And some users, particularly for new users, so you may have a problem to run this command to find the path, right? So, and originally we create a script, so you don't need to find the path. You just need to run 2 commands to set up a path and run from a script created by us called run MCR. So those scripts actually ran for the old and R 2018 net versions, and afterwards it didn't. It's out of dated. So we'll try to fix that problem, and hopefully will not need you to come to find the path of MCR anyway. So in that case, on all the time, you can just run from the script we give to you, and then your code can run without going to find the path or something like that. Right now, if you use any versions after that, you will run into trouble, and it's basically give you it's not a run, and you have to add that path as a should. I think I will stop here today, and we have a Alliance online wiki documentation from MATLAB. So you go to that documentation, they have some explanations and examples and on that wiki page. And then if you have any further questions, you're always welcome to email support at Alliance. And our supporting online wiki ticketing systems. We're trying to help you as soon as possible. Okay, thank you.